Okay, welcome to page 3 of the 4548 study guide. This section is on 4.5 and 4.6, graphing sine, cosine, secant, cosecant, tangent, and cotangent. All right, so when we're graphing a sine function, and for these problems on page 3, all of the attributes were given to you. So we have the amplitude, the period, the quarter period, the phase shift, and the vertical shift. So what we're going to do is using these attributes, we're going to assume we are going to draw a positive version of each of the 6 functions, starting with a sine curve. So for our sine curve, we start with our phase shift is our first x value. So phase shift of negative pi over 2. So negative pi over 2. And then we add quarter periods to our phase shift to generate these additional x values. So we add and we get 0. Then we get pi over 2. Continue to add quarter periods, so we get 2 pi over 2, which will reduce to pi. Then add one more time and get 3 pi over 2. So we have those 5 x values. So notice how those 5 x values appear on this graph at negative pi over 2, 0, pi over 2, pi, and 3 pi over 2. So those are our 5 key x values. Our y values are generated by the middle one. The middle y value is our vertical shift. So our vertical shift here is 1. And then we go up and down the amplitude. So up 2 to 3, down 2 to negative 1. So our y values are up here at 3, right here at 1, and right here at negative 1. So we have those 3 y values. So now we are ready to plot the points of our graph. So for a positive sine curve, for any type of sine curve, our first dot goes at our middle y value, here at 1, at the first x value. Then we go to the next x value, 0, and it goes up to 3. Then down back to the middle, down to the bottom y value, then back to the middle. Notice I'm only putting dots at the intersections of my key x values and key y values. And then I simply draw the curve. Let's do it in black. Passes through those points. And over this just one period of the curve, it does continue on in both directions infinitely. So that is our sine curve. All right, moving along to our cosine curve. It's going to have the exact same x values and y values. It's going to have the exact same x values and y values. So I'm just going to screenshot those in. So exact same x values and y values. So y values are still 1, 3, and negative 1. So we can mark those exactly the same. So negative pi over 2, 0, pi over 2, pi, and 3 pi over 2. Then our x values are still 1, 3, and negative 1. And of course, we need to have those labeled. And then now, we're ready to draw the dots again. So we start, so the difference with cosine compared to sine is that it starts in a different spot. Sine curves start at the middle y value at our first x value. Cosine curves either start at the top or the bottom, depending if it's positive, depending on if A is positive or negative. And it wasn't specified for this problem, but we're going to assume that it was a positive value of A. And so that means we're going to start up at the top. So first dot, up at the top. Next one, middle. And we're just following the normal pattern that every sinusoid, sine or cosine graph creates. Now I put that marking in the wrong spot for that last x value. That last x value should have gone at 3 pi over 2, not at, what is that? 5 pi over 4. Okay, and now we draw our curve. We can draw it in orange this time because why not? And there is our cosine graph. And again, it continues on infinitely in both directions. And that's the cosine graph. Okay, so for the secant curve, so now we are on to the cosecant graph, cosecant. So for the cosecant graph, what I'm actually going to do is I'm going to copy over the sine graph, because when we graph a cosecant, remember, cosecant theta is the reciprocal of sine theta. It equals 1 over sine theta. So we know the whole process with graphing cosecant involves us completely graphing sine first. So I'm just going to copy over this sine graph that we already created, but instead we're going to treat this as if we were doing cosecant the whole time. So instead of sine, we're doing cosecant, which remember is abbreviated CSC. So cosecant. So far we've drawn the sine curve. That's the first step when we're drawing a cosecant. But then there are two additional steps that we add in. The first is we draw vertical asymptotes at all the middle y values. What do I mean by middle y values? What I mean by middle y value is these three key y values. The middle one is 1. 3 would be the top one, and -1 would be the bottom one. So what I mean by vertical asymptotes at all the middle y values is we want to literally draw a vertical asymptote at the middle y values. So let's do that. So vertical asymptote at the middle y values. I'll do this in red. So vertical asymptotes here at this, everywhere your sine curve crosses the middle y value. So all of those dots. So one there at x equals 1, or sorry, at x equals -π/2. One there at x equals +π/2, and one here at 3π/2. And then the second step is to connect curves to the other dots, meaning the ones at the top and bottom y values, that are opposite the curvature of the sine graph. So, not a great explanation, a little clunky, if I'm being honest, but here's the idea. So we connect curves to the other dots, meaning the non-middle dots. So our top one and our bottom dots here, the top and bottom of the amplitude, the peak and trough, that are opposite the curvature of the sine graph. So the curvature of the sine graph right there is an upside down U. So instead, I'm going to make it a right side up U. And it's going to follow those asymptotes. Same thing over here. This is a right side up U. So my cosecant curve is going to be an upside down U. And those red curves, the black curve, remember, is a sine curve, but those red curves is our cosecant curve. All right. So now moving on to secant. A secant curve actually is the same thing as well. If we're doing a secant curve, it involves that same thing. But remember, secant is the reciprocal of cosine. It's 1 over the cosine function. So instead of drawing the sine curve, we draw the cosine curve. So instead of redrawing cosine, I'm just going to bring the one in I've already done. So our secant curve, we're going to change this into a secant rather than a cosine. And remember, secant is abbreviated SEC, like the conference. And when we're doing a secant curve, we do the same exact steps that we did for cosecant. but instead we are applying them to a cosine graph rather than a sine graph. So we know secant is 1 over cosine, which is why we start with the cosine graph. But then we follow the 2 same extra steps. We draw vertical asymptotes to the middle y values. So notice the middle y values are in different spots compared to the cosecant. Cosecant, they were at the first, third, and fifth. For secant, they're just going to be at the second and the fourth. So those are where our 2 vertical asymptotes are going to end up falling. And then we do the same thing. Connect curves to the other dots, the ones we haven't used yet. So we already used those 2, the second and fourth. We got to use this one and then those 2 on the edges. So we connect curves to this dot here and reverse the curvature of the cosine curve. This would instead be cosine. So this is a right side up U, so I make it into an upside down U. This, we have a half upside down U, so I make it into a half right side up U. Here we have a half upside down U, make it into a half right side up U. That is how we graph a secant curve. Okay, moving on to tangent. This doesn't really have much to do with sine or cosine, besides the process is similar to finding the key x values and y values, but highlighting a couple differences. So when we're doing tangent or cotangent, so the couple of differences there are with tangent and cotangent is how we find the period is different. But because, remember, the period equals pi over b for tangent and cotangent rather than 2 pi over b, but that difference doesn't manifest itself because the period was given to us for this problem. So that difference does not manifest itself. The other difference with a tangent curve is that the phase shift goes in a different spot. The phase shift goes in the third x value rather than the first, like in all the others. So remember, tangent, phase shift goes in the middle. Cotangent is like all the others where the phase shift goes first. So that's the other major difference between tangent and cotangent and the others. So our x values are going to be different here because our phase shift, when it goes in the middle, is going to shift all our x values over. So putting our phase shift in the middle and still adding quarter periods, so negative pi over 2 plus the quarter period, which is pi over 2, would get me 0, plus the quarter period again gets me to pi over 2. So those are my last 3 x values. To get these first 2, I simply subtract the quarter period. So I do negative pi over 2 minus pi over 2, and I'm at negative 2 pi over 2, which I could simplify, but I'm not going to yet. Then I subtract it one more time, and I get negative 3 pi over 2. So that's how we get our x values for a tangent curve. Same concept, it's just we're subtracting left on the number line rather than adding to the right. Okay, so negative 3 pi over 2, negative pi, that's our negative 2 pi over 2, negative pi over 2, 0, and pi over 2. So those are our 5 key x values for this tangent curve. Okay, and then we have our y values, they're the same as they always are. Vertical shift in the middle, vertical shift to 1, up and down the amplitude, so 3 and negative 1. So our key x values are still, our key y values are still 3, 1, and negative 1. Okay, so now, when we're drawing a tangent or a cotangent curve, it's always the same pattern. In terms of our x values, there are we start by putting vertical asymptotes at the edges. So we put, so number 1, vertical asymptotes at the edges. And by edges, I mean x sub 1 and x sub 5. So those are the edges of our function. So there won't be dots there. Instead, there will just be vertical asymptotes. So we have a vertical asymptote at our farthest left x value and our farthest right x value. Okay, then all we have to remember is, does the tangent function go increase as we go or decrease? Because tangent and cotangent are very simple. They will always, for our x2 through x4, they'll always go either bottom, middle, top, or top, middle, bottom. And what we have to remember is that a positive tangent curve is upward sloping. It looks like this in between our asymptotes. So it goes bottom, middle, top. So at the second x value, we're at the bottom. Middle x value, we're in the middle. Third x value, we're at the top here. And then I just simply draw a curve that passes through those points and approaches my asymptotes as x approaches them. And that is my positive tangent curve. A negative tangent curve would just do the opposite. It would have gone down, and it would have started at the top, gone to the middle, went through the bottom, then kept going down. So that's our positive tangent curve. Finally, we have our cotangent curve. Our cotangent curve has the exact same x values as the four other ones we started with here, because just like them, the phase shift goes first. Now, again, I'm going to repeat. The period would not be the same for cotangent as it would be for secant, because remember, the period for a cotangent is pi over b rather than 2 pi over b. But because the period was given to us, that difference did not manifest itself. So all of our x values are the same as they were before, starting at our phase shift and adding quarter periods as we went through, all the way through. So our x values are still the same. They're these purple ones, starting at negative pi over 2, 0, pi over 2, pi, and 3 pi over 2. And then just like with tangent, getting ahead of myself, the y values, starting at vertical shift of 1, up and down the amplitude. Even though technically tangent and cotangent don't have an amplitude per se, we still treat it like an amplitude in that it passes those three y values are points that our line passes through. Okay, and then it has the same steps that we go through for graphing it. So there still are vertical asymptotes at the edges. So vertical asymptotes at the edges, let's mark our x values, 1, 3, and negative 1. So we still have vertical asymptotes at the edges. So vertical asymptotes, we can use red this time. So vertical asymptotes at those two x values. Again, that uses up those x values, so our dots only go at x2, x3, and x4. So if we wanted to finish this up, we would say dots, or the points at x2, x sub 2 through x sub 4 in from top to bottom for a positive cotangent function. So for a positive cotangent. So if it's a positive cotangent function, instead of going bottom to top like tangent did, it goes top to bottom. So we can use orange here to make our dots. So first one goes up top, second x value, up at our top y value. Second one down at the middle, and third one at the bottom. And then we just make our curve that passes through those points. Not the best drawn curve, but it does the job. So notice how for a positive cotangent, in contrast with the positive tangent, it always goes bottom, top, then middle, then bottom at our three middle x values, rather than bottom, middle, top. Now, a negative cotangent would do the opposite. So negative cotangent, the dots look the same as a positive tangent, but they will have different x values, which is what differentiates them. So that is how we do different versions of those 6 different trig functions if we were given the attributes. Next, I'm going to do 6 other examples, all different problems where we can practice finding the attributes as well. So check out the next video.